students. In this video, I am going to discuss about molecular orbital theory, paramagnetic, diamagnetic substances, and within 1 minute how to find out paramagnetic, diamagnetic, and bond order, bond length, bond energy. And after these two topics, I am going to give explanation dipole moment also, dipole moment. Okay, these three topics I am going to cover in chemical bonding. So first, let's begin with molecular orbital theory. So generally, what type of questions they are asking based on molecular orbital theory? Based on that, I am giving the concept to you. Okay, molecular orbital theory. It is also called as MOT. Theory explanation also there, students. This method also called it as LCAO method. Linear combination of atomic orbitals. Briefly, I am giving points. Linear combination of atomic orbital. Okay. So this linearly, two atomic orbitals linearly combining, finally we will get same number molecular orbitals. But this molecular orbitals again two types. Molecular orbital, one is, so finally we will get molecular orbital. This molecular orbital we have two types. One we call it as bonding molecular orbital having low energy. Another one is anti-bonding molecular orbital. So this is theory explanation type. Theory explanation. But towards competitive I am concentrating more. Within 1 second, within 1 minute, less than 1 minute how to give answers. Based on that I am giving some shortcuts to you. Definitely it will be helpful for you during examination. Okay. So first question from MO theory they are asking, He2 molecule, Be2 molecule does not exist. He2, Be2 molecules does not exist. What is the reason does not exist? Due to bond order is 0. Bond order 0. So according to MO theory, we are giving three conclusions, students. We are going to find out bond order. What is the bond order formula? Half into number of bonding molecular orbital electrons minus number of anti-bonding molecular orbital electrons. Like that we are taking bond order generally for theory concept type. But no need. This formula also no need. We have another shortcut I can show now. Next, bond order where it is 0, that will not exist, right? Helium and helium, between helium, there is no bond. It will not exist. Between beryllium and beryllium, there is no bond. That's why bond order is 0. It will not exist, right? Helium atom also representation He, helium molecule also representation is He. Depends on the concept we are talking. It is atom molecule. It has van der Waals radii. Noble gases, there is no bond. Already we have studied when we are in chemical. What is this? Covalent radius, right? Covalent radius, atomic radius, covalent radius, van der Waals radius, metallic radius. Already we have discussed in the previous videos. If you have any queries, please go through that. Now next one, He2 molecule, Bu2 molecule does not exist. What is the reason? Bond order is 0. Next one, students, here either homomolecules or heteromolecules, which is having 14 electrons, one type of configuration. The following configuration exhibit. What is that? I can show now. Okay. If you have any queries, doubts based on diagram, you can comment me, students. Definitely coming days I can show the diagram also. But during competitive examination, no need of diagram. Okay. So now I am writing the that. What is homo molecule? First of all, homo is nothing but same atoms. same elements. If you look into N2 molecule, N2, 7 plus 7, 14 electrons, right? But both are nitrogen. If you look into carbon, having 14 electrons and less than 14 electrons, that is also you can write, students. Homo molecules are hetero molecules which is having less than 14 electrons. 14 electrons, less than 14 electrons. Please make a note, this one, less than 14 electrons and 14 electrons following this following configuration. C2 molecule, 6 plus 6, 12 electrons. Okay. So less than 14 electrons all, it can follow what I am giving the electronic configuration to you. Next, heteromolecule. What is heteromolecule, students? Two different atoms. If you look into the Cn minus 6 plus 7 plus 1. How many electrons, students? Yes, 14 electrons. Next, NO plus. See here, 7 plus 8 minus 1. 7 plus 8, 15 minus 1, 14 electrons. See? So either homo molecule or hetero molecules, all are having 14 electrons and less than 14 electrons. The following configuration it exists. What is that? I am writing here. Sigma 1s, that is less than or equal to sigma star 1s. Sigma 2s, less than or equal to sigma star 2s. And here important point, pi 2px equal to pi 2py, that is less than sigma 2pz, that is less than pi star 2px equal to pi star 2py, that is less than sigma star 2pz. See, 1s means immediately star 1s, 2s means immediately star 2s. This combination, pi 2px, pi 2py, pi bond. Here lateral overlapping, that's why pi bond formation. Here axial overlapping, sigma bond formation takes place. I said just now, if you have any queries, theory explanation, comment me, I can explain. Otherwise, competitive, I can concentrate in this video. Okay, pi, same thing it will repeat. Okay, clear, students? That's it. Now next one, fourth point. Above 14 electrons, greater than 14 electrons, following configuration exhibits, or following configuration takes place. Your wish. Okay, write down same. Sigma 1 is, sigma star 1 is, sigma 2 is, sigma star 2 is. Next one, what is this next one? Here volta. This, please try to understand, students. You have to keep it in mind. Here change is there. Here just a volta, reverse this one because of symmetry. So sigma 2pz, that is less than pi 2px equal to pi 2py. That's all. Remaining everything is same. Only one part is different. Clear, students? That's it. Pi star 2px equal to pi star 2py, that is less than or equal to sigma star 2pz. Clear, students? This is above 14 electrons. Like examples I am writing here. Suppose NO minus 7 plus 8 plus 1, 16 electrons, right? This is heteromolecule. Homo molecule, O2 means 8 plus 8, 16 electrons. Above 14 electrons, following configuration takes place. That is homo and hetero molecules. Both. Okay. I gave clear explanation. Homo is nothing but same elements. Hetero is nothing but two different elements. So finally, you have to calculate electrons. If it is less than 14 electrons, go for this. If it is above 14 electrons, go for this. Clear, students? So based on previous year questions, based on commonly asking questions, I am making video. This one definitely it is helpful for you. Now, next one, students. Yes. Here we are going to discuss bond parameters. Already I had given explanation bond parameters. Bond order directly proportional to bond energy. Previous video I had explained bond parameters, but this is next concept. Here also we can discuss. Bond order directly proportional to bond energy. Bond energy also call it as bond enthalpy. Bond enthalpy. Okay. So next one, bond order inversely proportional to bond length. Inversely proportional to bond length. Okay, that's it. Bond order directly proportional to bond energy, bond order inversely proportional to bond length. Okay, students, examination time, they may ask bond order, they may ask bond energy, they may ask bond length also. First one, how to find out bond order within a minute. Now I am going to discuss the shortcut, students. See, you'll enjoy this one. So first one, I am going to calculate number of electrons. Then I am going to give bond order. Okay. See here, 14 electrons. The system which is having 14 electrons, either it is homomolecule or heteromolecule, 14 electrons. Next 15 electrons, 16, 17, 18. Next, what about this guy? 13, 12, 11, 10 electrons, right? Which is having 14 electrons, its bond order is 3. Best example you can notice N2 molecule, 7 plus 7, right? N2 molecule, what is the bond order? 7 plus 7, 14 electrons means between nitrogens 3 bonds are there. Bond order is 3 is nothing but what, students? Bond order is nothing but between two atoms, between two atoms, 3 bonds are present. Suppose you are getting bond order is 2, between two atoms, 2 bonds present. If you get bond order 1, between two atoms, number of bonds is 1, like that. Okay, next, not only homomolecule, heteromolecule, Cn minus, 6 plus 7 plus 1, totally 14 electrons. See, even here also bond order is same. Right, wherever 14 electrons is there, its bond order fixed. After that, just 0.5 you can decrease. 0.5 you can decrease. That's all your answer. If you calculate oxygen molecule, yes, O2 molecule between oxygen and oxygen, double a bond. If you calculate theory explanation time, if you calculate also above configuration, you can take it and check it. So you'll get bond order is 2. Okay. So here also 0.5 you can decrease. That's all your answer, students. Clear? See, if you know bond order, you will come to know bond energy. If you know bond order, you will come to know bond length. Now, bond order very easily we can calculate here, right? Now, I am going to show one example, students. See here, O2, O2 minus, O2 2 minus, O2 plus, oxygen molecule species. Oxygen molecule and its species. Molecule, species. Here they are asking 3 bond parameters. 3 bond parameters. Can you try this answer, students? What is this? Bond order they are asking. Next, bond energy they are asking in exams. And the last category is, what is that? Bond length, right? Bond length. Okay, now go for calculation first. O2 molecule. O2 molecule means 8 plus 8, 16 electrons. It is neutral molecule, 16 electrons. What about O2 minus? O2 minus is 8 plus 8 plus 1. What is this? 17 electrons, right? Next, O2 2 minus, students. O2 2 minus means how to calculate? 8 plus 8 plus 2. Totally 18 electrons, right? Next, O2 plus. O2 plus means 8 plus 8 minus 1. Then what is this? 15 electrons. That's all. If you know the electrons, then we can use the shortcut. What is the table here? I gave here. Yes, that's all. This you can follow. Can you tell 16 electrons means what is the bond order? 2. 17 electrons means what is the bond order? 1.5. 18 electrons means 1. And 15 electrons means C, 2.5. So finally, in which case it is more? Yes. Which case it is more? 15 electrons, right? 15 electrons bond order you can write. That is 2.5, right? See how easily we are working questions. O2 plus greater than. Afterwards, which is having 16 electrons, O2, 2. Next one, 1.5. 17 electrons means 1.5, O2 minus. And the last one is O2, 2 minus, which is having 18 electrons. Clear? This is bond order. Is it clear, students? This is what? 15 electrons where it is 2.5. 16 electrons, 2. O2 minus. O2 minus means how many electrons? 17 electrons means 1.5. Next O2 2 minus 18 electrons. Clear? Now you can write the same order, bond energy. Right? So bond energy directly proportional to bond order. C simple ma. C single bond, C double bond, C triple bond, C. So here easily we can break the bond. Here it is little difficult. Here more difficult. Fighting with one person is easy. Fighting with two persons difficult. Fighting with three persons is more difficult. More energy is required to break the bond. Right? Like that you can connect the questions. The same order, no change. What about the last one, students? Yes, bond length, just ulta. Just ulta. O2 2 minus, that is greater than O2 minus, that is greater than O2, that is O2 plus. See, here number of bonds increases. What happened? Bond length decreases. Close each other, attracting each other strongly. Then come close. Come close means bond length decreases, right? So finally, bond order inversely proportional to bond length. See, students, how easily we are working within minute, right? So now, next, one more question I am giving. Everyone try this one and comment me answer. Next question 2, I am giving NO, NO plus, NO minus. Bond order and bond length. Please everyone try to this question and give me answer in comment box. Okay. NO, NO plus, NO minus. Same, you can take the table, calculate electrons, pick out bond order, then bond length both. Clear? Now, next one, paramagnetic, diamagnetic. MO theory, frequently we are seeing three models. Model 1 is whether it is existing or not, they are asking. Model 2 is either electronic configuration based on bond order, bond parameters. Bond order, bond parameters plays very important role in MO theory. Afterwards, they are asking paramagnetic and diamagnetic substances. Okay, so actually theory explanation time we know. Suppose what is this? The given box condition is like this, unpaired electron. So then what we call it as unpaired electron is there, what we call it as students? Paramagnetic, right? But paired electrons is there, what we call it as students? Diamagnetic, right? But always we are taking the diagram and finding out paramagnetic, diamagnetic, it will take lot of time. To save the time, again I am giving here one best shortcut to you. What is that, students? Odd electrons, right? Odd electrons shows paramagnetic nature. Odd electrons paramagnetic in nature. Clear? Next point. Even electrons, even number of electrons, diamagnetic in nature. Diamagnetic in nature. Clear? Right? Suppose one electron is there like this. If two electrons is there, it will pair, no? Like that. Right? Now, next most important point is, here only most of the students are confusing, which is having exceptional case, students. This is exceptional. In organic chemistry, where is exceptional, it plays important role. Which is having 10 electrons, and C, 16 electrons. See, 10 electrons, 16 electrons, actually we expected diamagnetic because it is even number. But it is exceptional case which is having 10 electrons, 16 electrons. I am writing examples here itself. B2. See, 5 plus 5, 10 electrons. Even oxygen molecule. See, 8 plus 8, 16 electrons. Not only homomolecules, it's species also, which is having 16 electrons, which is having 10 electrons. Definitely, it is paramagnetic. Actual expected diamagnetic, but it is showing paramagnetic in nature. According to MO theory, oxygen is paramagnetic due to the presence of two unpaired electrons, pi star 2px, pi star 2py. So that we already discussed in concept explanation time, right? So still if you have any queries, there is no problem. Comment me that I can show diagram in coming videos. Okay. Now next one. I am giving some examples. Lithium. Lithium, how many electrons, students? 3 electrons, right? 3 electrons means it is odd. Odd means para, right? Next to lithium plus. Lithium plus actually 3. Now one subtract. So 2 electrons. 2 electrons is diamagnetic. That's it. Easily you can work out. Next beryllium, boron. Boron means 5 plus 5, 10 electrons. See students, here you have to concentrate. Exceptional case, no, it is paramagnetic. Next O2 molecule, 8 plus 8, 16 electrons, but it is exceptional case. Exceptional cases. Okay, exceptional cases we have to concentrate more. Next one, they gave question like this, NO minus. NO minus means 7 plus 8 plus 1. See students, 15 plus 1, 16 electrons. See 16 electrons again paramagnetic. Next NO plus. NO plus means 7 plus 8 minus 1. 15 minus 1, 14. 14 electrons means it is diamagnetic. Right. Next to Cn minus. 6 plus 7 plus 1. How many electrons, students? Here also 14 electrons, diamagnetic. Both having same bond order. If they asked bond order, you can write NO plus equal to Cn minus. Okay, this is also one of the repeatedly asking questions. Now, next another species. Yes, O2 minus, O2 2 minus, O2 plus. Can you try this one, students? 8 plus 8 plus 1, 17 electrons. It is paramagnetic, right? So here 8 plus 8 plus 2, 18 electrons. It is diamagnetic. 8 plus 8 minus 1, 15 electrons. It is paramagnetic. Like that, easily we can work out the question. Here, with this molecular orbital theory, what they are asking repeatedly in examination, NEET level, mains level, advanced level also, I have covered here, students. Okay. Now, next interesting topic is dipole moment. Dipole moment. Dipole moment. See, students, here this is also called it as, we are finding here polarity. Polarity. Polarity in a given molecule. We are finding here polarity in a given molecule. See students, to understand more polarity, I am giving one example. Suppose, example like this, Cl2 you have taken. Cl, 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 Cl. See here, this is electronegativity is 3.1, this is also electronegativity is 3.1. So here no one is taking electrons mutually sharing. Both are same electronegativity, no mutually sharing. There is no polarity. Polarity is nothing but opposite charges. Polarity is nothing but opposite charges. When opposite charges develop, if different electronegative atoms are there, if the same Cl combines with HCl, see, his electronegativity is 3.1, his electronegativity is 2.1. So, who is more electronegative? Chlorine. Definitely, he attracts electrons towards itself. Such a way, what happened here? Partial negative charge developed. Partial negative charge developed. See, HCl minus, this is partial positive charge. This is, we call it as dipole moment. Simply you can remember two poles having opposite charge. It is not correct definition, ma. To understand easily I am telling, two poles having opposite charge. Two poles having opposite charge. Two poles having opposite charge. See, here two opposite charges are there. Definitely here polarity is there. That means in maybe how much percentage we don't know. That also we are going to calculate here. Covalent character, ionic character, we already discussed one video, Fazan's rule. If you have any doubts also go through that topic. Okay, and the next one more point. Yes. HCl molecule, you cannot say here 100% covalent, but this one you can say 100% it is covalent. 100% it is covalent, but you cannot say it is not 100% covalent. Okay, maybe majority is covalent, but some percentage definitely ionic nature. Ions are developed, no? Ions developed, no? How can you say it is pure covalent bond? Pure covalent bond is nothing but non-polar. This is non-polar molecule, no polarity. This is polar molecule. Did you understand what is the difference between polar and non-polar? Okay. Now what is the dipole moment representation? Mu. That is delta into, what is this? L. What is delta here? This is charge. This is what? Length or distance, your wish. And some textbooks they had given Q into D also. Both are same. This Q is nothing but charge and D is nothing but distance. Numerical part many times we are only. Okay, students, in this part I am going to discuss dipole moment, all theory questions. Next, some numerical part also there. Numerical part we will discuss in the next video. Otherwise, it will be more lengthy. So almost it is 26 minutes now. That's the reason. Now see students, I am giving some important points. Within minute we have to give answers. Symmetrical molecules dipole moment 0. Dipole moment 0. The most important point. Okay, so look into this. I am going to discuss the point here. Suppose if you have taken CO, carbon monoxide, carbon dioxide I have taken, carbon dioxide. Between carbon and oxygen, who is more electronegative? Oxygen is more electronegative, 3.5, this is 2.4 something. Difference is there means definitely opposite charges develops, right? And dipole moment, next important point is dipole moment is vector quantity. Dipole moment is vector quantity. Vector quantity. It has both magnitude and direction. It has both magnitude and direction. Magnitude and direction. Is which side attracting electrons, towards that side you have to show dipole moment. It has both magnitude and direction, opposite charges. That's all, students. You have to understand clearly here. I am telling here one point. See here, students, it seems to be two different electronegative atoms. We expected this case is polar, but it is non-polar. But it is non-polar. What is the reason? Total angle. This is linear molecule, right? Linear molecule bond angle, total bond 90 degrees. But here, one direction it is showing plus 90. Plus 90. Exactly opposite direction means minus 90. Plus 90, minus 90 both gets cancelled. Finally, CO2 molecule dipole moment is 0. Dipole moment is 0. That's why I said symmetrical molecules. Symmetrical molecules is nothing but there is no lone pair. There is no lone pair. All are bond pairs. All are bond pairs. I'll write all the points. Actually, students after seeing carbon and oxygen more electronegative, oxygen is two different atoms means definitely polarity will develop. This is polar molecule they are writing, but it is finally non-polar. What is the reason? Sum of the dipole moment is 0. At least one opposite direction is there. Definitely that is 0. Okay. To understand this one, take one more example. one more example which is frequently asking in examination. So that is what? CCl4 molecule, carbon tetrachloride. See, carbon, Cl, and this is Cl, Cl, Cl. Here between carbon and chlorine, who is more electronegative? Chlorine. See, this is also chlorine, this side. See, at least one opposite direction, its dipole moment is zero. Expected polar, but it is non-polar, non-polar. So finally what I am saying here, all symmetrical molecules, dipole moment zero. What are symmetrical molecules? Only bond pair, no lone pair. Okay. So now I will cover all theory questions here, students. Next video, I am going to discuss its important numericals under dipole moment and day-to bond explanation. Also, symmetrical molecule, AB4 type. AB4 type. First, let me write AB2. From beginning, I will come. AB2. Yes. AB2 type means A is nothing but central metal atom, the next B is nothing but bond pair, bond pair. So AB2 type, so like BCl2 molecule, CO2 molecule, like these are all molecules, dipole moment is zero, symmetrical molecules. Why? Because no lone pairs. Okay, no lone pairs. Next to AB3 type, AB3, BF3, like BCl3 and all boron halides, BX3, BI3, like all dipole moment is zero because it is trigonal planar. Here also no lone pairs. Next AB4, AB4 also no lone pairs. Here CH4 molecule, CCl4 molecule, SO4 2 minus molecule, all species also it will come. NH4 molecule which is having a tetrahedral shape, and the next one, what is the students? No lone pair. That's all. Next AB5, AB5 best example PCl5, PCl5. See all gets cancel each other. If you want to see PCl5 molecule, you can see PCl5. Trigonal bipyramidal. This is Cl. Okay, and see students, this is trigonal, and the bipyramidal is nothing but one above, one below. So this is compared to this one, phosphorus and chlorine. Chlorine more electronegative. Here chlorine more electronegative. At least one opposite direction. And here towards this one chlorine, towards this one. See, this gets cancelled. I mean these two and this one finally gets cancelled. Dipole moment is zero. Like this. Next AB6. AB6 means SF6. SF6 octahedral shape. Octahedral shape. Okay, already we have discussed a hybridization topic, their shapes and all. Here directly I am giving questions. AB7. AB7 means like IF7 molecules and all. Dipole moment is zero. So here majority of the examples we have covered. And another example, students, and which is frequently asking in exam. Yes. NH3, NF3. This is one of the frequently asking question in all examinations. NH3, NF3, both are pyramidal shape. Both are pyramidal shape. But NF3 dipole moment less than NH3. Okay, why? What is the reason? See students, you can draw the structure first. NF3 and NH3 both are sp3 hybridization. It has one lone pair. You can write expanded form like this. Okay. Now NF3 also same thing. It has one lone pair. Fluorine, fluorine. Okay, now see, compared to nitrogen and lone pair, which is more electronegative, definitely lone pair electrons only dominate. He is more electronegative. Direction you can show. But compared to hydrogen and nitrogen, see, nitrogen only. It is going same direction. Same direction means not equal to 6. But here Your lone pair is there, definitely more electronegative. But this is the opposite direction. Wherever you will get opposite direction, mu equal to 0. It is not exactly 0, ma. 0.3, very less value, very less value. Here you will get 0.8 dB units. And the dB units, your dipole moment, important role, 1 dB, we are expressing in dBs. 1 dB equal to 3.33654 and 10 to the power of minus 30. So I am going to give the values and numericals in the next video. Okay, students, here dipole moment. Here also not equal to 0. Here 0 point something you will get value, 0 point something 3 value like this. Okay, W units. The last questions. BF3 dipole moment, NH3 dipole moment, NF3 dipole moment comparison. Definitely BF3 is very less. Why? Here there is no lone pair. Definitely dipole moment is 0. Why? Because boron trichloride, S2 hybridization, C, trigonal planar opposite direction, at least one opposite direction is the dipole moment is 0. No, it is completely 0. Next one, which is having more, which is having NH3 is more. Finally, NH3 is more. This is one of the frequently asking questions. See students, your NH3 is greater than, next to NF3 is less when compared to BF3, it is more, when compared to NH3 it is less. We expect questions like this dipole moment. And electrostatic units, Debye units, electrostatic units, next to Coulomb meters, all values I will give. And a percentage of ionic character calculation also dipole moment plays important role, students. I'll discuss on the questions next video. And most of the students ask me, what is this day-2 bond, coordinate covalent bond explanation also. I'll give in the next video. Thank you, students. Thanks for watching. And please inform to others also, definitely who are preparing for mains, NEET examination and advanced examination. Our videos definitely give the good improvement and good marks. Okay, during examination competitive especially we need the shortcuts, right? So if you have if you know more shortcuts in chapters, definitely you save the time during examination. Coming videos also I am going to give more easiest shortcuts. Okay. Thank you, students. Thanks for watching. Please inform to others and subscribe our channel. You will get daily updates. Thank you.